In fact, you really won't even need to, it'll figure out what you probably want and do what you probably want without you even having to ask.
By 2035, we'll be short about 75 million workers, which means big gaps in jobs like elderly care, delivery services, and construction. Meanwhile, Figure 01 lacks large-scale production data. Digit V4 from Agility Robotics may walk on 2 legs and serve as a warehouse bot for Amazon, but its dexterity is limited. Sanctuary's Phoenix V3 has soft hands, but suffers from a high burnout rate and subpar safety standards. In contrast, Tesla's Optimus Gen 3 has completed its initial pilot production phase. With Dojo-powered data systems ready to go, it's preparing to hit the market at an estimated cost of just $20 per hour, with the ability to operate 24/7 and potentially break even within just 18 months. Each software update brings new at-home capabilities, cleaning today, fixing a leaky pipe tomorrow. And just recently, Tesla's viral household demo of Optimus captured the public's imagination, offering a clear reason for Elon Musk's confidence when he said,
Who wouldn't want their own personal C-3PO R2-D2? I think that's a reasonable target.
So why exactly is Elon Musk so confident about the latest version of Tesla Bot Optimus Gen 3? What updates are coming soon? How much will it cost? And will we really get to welcome these robots into our lives, just as promised? Let's dive deeper in today's episode of Tesla Car World. So, how is the Tesla Optimus Gen 3 being shipped?
It's going to grow very fast. I think humanoid robots will be the biggest product ever. The demand will be insatiable.
Just 2.5 years ago, Tesla's very first Optimus robot took its shaky first steps on stage during AI Day 2022. At the time, many critics didn't believe it would ever make it out of the lab. But Elon Musk stood firm, saying that humanoid robots would become the biggest product ever and that the demand for them would be insatiable. Now, fast forward to April 23, 2025. In Tesla's latest shareholder letter for the first quarter, a photo showed 9 shiny Optimus Gen 3 robots lined up on an assembly line at the Fremont factory. The caption was short and sweet. Optimus pilot production line now online. But during the earnings call, Musk gave more details.
But we expect to have several thousand Optimus robots produced and doing useful things by the end of next year in the Tesla factories. And then in 2026, ramping up production quite a bit. At that point, we'll be providing Optimus robots to outside customers.
Tesla has also officially confirmed a plan to build 5,000 robots in 2025. This will serve as a kind of stress test within the company before opening up orders, first for businesses and later for everyday people and families. At the same time, a video went viral on X, showing the Gen 3 robot doing real household chores, stirring a pot on the stove, vacuuming the floor, and wiping crumbs off a kitchen counter, things that would have knocked earlier versions off balance. Elon Musk didn't hold back, calling Optimus Tesla's biggest ever product. The public reaction came fast. While other home robot companies like Figure, Agility, and Sanctuary had only shown carefully staged lab demos, none had released unedited footage of their robots working in a real home. The general feeling? Tesla's Gen 3 had taken a major step forward, finally crossing that tricky line between cool idea and something truly useful in everyday life. How is Tesla Bot Gen 3 learning through video imitation and self-play?
It's going to take a lot of compute resources, and it'll take time. I think there's certain threshold breakthroughs that we think we can achieve, where if Optimus can watch videos, YouTube videos or how-to videos or whatever, and based on that video, just like a human can, learn how to do that thing, then you really have task extensibility that is dramatic, because then it can learn anything very quickly. So I think we'll get there.
Elon Musk recently talked about what he called a very important breakthrough: the idea that a robot like Optimus could learn just by watching a video. He explained that if Optimus can watch a task on YouTube and then do it on its own, the number of things it could learn would skyrocket. In his words, task extensibility becomes dramatic. It can learn anything very quickly. At one time, that might have sounded like science fiction, but now it's starting to feel surprisingly possible.
XAI is building the most powerful. We have the most powerful. I think we have the most powerful training cluster in the world right now, which is over 200,000 GPUs training coherently.
One of the critical pieces of technology is an AI model that understands the world. Just as we have an AI model that understands language now with ChatGPT and Llama and such, we need a world model, a language model of the world.
Unveiled at Consumer Electronics Show 2025, NVIDIA's Cosmos is a breakthrough in robotics and AI, a suite of what they call world foundation models. These models are trained on millions of hours of driving and robotics footage, and they don't just recognize objects, they understand the real-world physics behind them. Everything from gravity to friction to inertia is built into their reasoning. That means Cosmos can generate lifelike, consistent behavior over time, whether it's used in simulations or directly powering robots through AI decision-making networks. NVIDIA CEO Jensen Huang even called it the missing language model of the physical world, a bold claim that has quickly gained traction. One of the most impactful aspects of Cosmos is that it's been released under an open model license. That gave Tesla the chance to fine-tune it, using its own massive data trove gathered from its global fleet of vehicles and robots. The result is a highly efficient hybrid model, specifically tailored for robotics, that learns faster and performs better than anything before it. Backed by Tesla's powerful Dojo supercomputer, the system can now absorb tens of millions of real-world scenarios each night. When a new policy, a kind of learned behavior, passes a series of safety checks, it's immediately sent for hands-on testing at the company's Fremont factory. And the results have been impressive. Internal reports say that Tesla's Optimus Gen 3 robot now only needs about 40 minutes of guided training to handle a brand new object, whether it's something as everyday as a kettle or a tricky item like a dog leash. In May 2025, a now viral video posted on X showed Optimus Gen 3 performing household tasks in a real Tesla staff member's home, not a carefully staged set. The robot successfully used 5 different tools, including a vacuum, mop, spoon, pan lid, and dustpan, all without falling or making any critical errors. Meanwhile, at the Fremont facility, early versions of the robot have been sorting interior clips for the Model Y at a rate of 23 items per minute, approaching human speed. Even more exciting, the robots are recording ergonomic data to help design better joints and movements for future generations. In simulated training, the progress has been just as dramatic. A batch of 500 Optimus bots running in virtual self-play managed to complete a shape-sorting task with 98% accuracy after just 16 CPU hours, an 80-fold speed improvement over the same task last year. Taken together, these breakthroughs make Elon Musk's famous comment, "You really won't even need to figure out what you want. It will probably know," feel a lot less like science fiction and a lot more like the near future. Why can Tesla Optimus Gen 3 perceive as an independent human? The proximate cause is the scale and architecture of the computer backbone Tesla and its sister company, XAI, have erected in Memphis. On 21st May, 2025, Elon Musk confirmed that Colossus, a repurposed distribution warehouse on President's Island, is already humming with roughly 200,000 B-class and AMD MI300X GPUs, delivering an estimated quarter exaflop of mixed precision throughput, 4 times the peak rating of the US DOE's Aurora supercomputer. While the figure is staggering in isolation, the strategic intent becomes clear in light of the construction permit filings Business Insider unearthed last month. A second hall, equal in footprint, is being outfitted to take the complex to 1 million GPUs by late 2026, backed by a dedicated 500-megawatt substation and $400 million in new transmission infrastructure. That electrical draw places the site in the same utility class as a primary aluminum smelter and exceeds the combined IT load of Meta's Printville and Google's Council Bluffs campuses. Tesla's in-house Dojo V2 nodes, built around a custom systolic array that excels at low-precision convolutions, are still on the payroll for perception pre-training and value function rollouts. Yet Musk's procurement rule is brutally simple. If NVIDIA is ahead, we buy NVIDIA. The result is a heterogeneous mesh in which visual contrastive learning runs on Dojo tiles approximately 0.34 joules per teraflop. Trajectory diffusion models grow on Blackwell GPUs, approximately 0.42 joules of energy, consumed for each teraflop of computation, and critic simulations execute on power-hungry but memory-rich MI300X boards. Router telemetry presented at a recent IEE Hot Interconnects workshop showed aggregate ring bandwidth of 24 petabytes per second, enough to shuffle the entire ImageNet corpus across the fabric in a third of a second. Why field an array that seems oversized even by hyperscale standards? Consider the data budget. A single 60-second training episode for Optimus, HD stereo video at 120 Hz, depth maps, 72 proprioceptive channels, 6-axis inertial measurement unit and spatial audio, occupies around 18 GB uncompressed. Tesla's current overnight curriculum, generated by Omniverse, emits roughly 12 billion such episodes every 24 hours. Feeding that torrent through a transformer stack with a 4-second temporal context demands close to an exaflop of sustained AI FP8 if policy refresh is to complete before the next day's shift begins. At the 48,000 GPU scale Meta disclosed for Llama 3, a single curriculum pass would stretch to 9 days, unacceptable when Fremont's body shop robots are waiting for a Monday morning firmware update. Energy cost is the governing constraint. Colossus Phase 1 operates at a power usage effectiveness of about 1.12, owing to direct-to-chip warm water loops. Every tenth of a PUE point recovered saves on the order of $25 million in annual electricity at Tennessee Valley Authority tariff levels. Internal cost models place Tesla's blended expense at 83 cents per billion tokens of embodied AI training, versus roughly $1.45 on equivalent cloud. 100 allocations, a 43% delta that compounds across trillion token schedules. Competitively, the gulf is widening. Meta's dual 24,000 GPU clusters, Google's estimated 75,000 unit TPU v6 pod, and Microsoft OpenAI's putative 100,000 GPU Azure array all target text-centric corpora. Humanoid control is 3 to 4 times heavier in sensory bandwidth, so compute headroom converts almost linearly into behavioral diversity. Early field telemetry bears this out. Gen 3 now masters an unseen household tool, say a stovetop kettle, in about 40 minutes of supervised fine-tuning, down from 5.3 hours on Gen 2, and hits 23 part picks per minute on the Model Y line while keeping joint motor-specific energy below 10 watts per kilogram. The conclusion is straightforward. Independent agency in robots is not an emergent mystery. It is a scaling law. By committing to a 1 million GPU footprint and a hybrid Dojo Blackwell-Rubin pipeline, Tesla has secured the computational substrate that turns raw, unlabeled sensor torrents into policies that approach the fluidity of human motor learning, but evolve at silicon speed. In this regime, what looks like excess is merely the minimum viable cost of teaching a silicon workforce to improvise in a world built for flesh and blood labor. How did Elon Musk confirm the production timeline of Gen 3? 23rd April. 2025 factory tour revealed that Tesla has carved out a dedicated 2,000 square meter high-mix, low-volume wing inside the Fremont Plastics shop to pilot build Optimus Gen 3. Within this area, 6 tightly choreographed work cells handle the entire mechanical flow. A 6-axis automated fiber placement head followed by an autoclave lays up each carbon fiber femur in 210 seconds, while holding a 98.7% yield. Nearby, a 4-kilowatt fiber laser welds torque-dense harmonic drives, rated at 15 Newton meters per kilogram, into the hip housings in 180 seconds, with 97.9% first-pass success. A third station outputs the 700-volt spinal power bus in 130 seconds at just over 99% yield. And the end-of-line rig uses structured light vision and a capacitive fixture to calibrate fingertip force sensitivity to within plus or minus 0.3 Newton, achieving a 99.6% acceptance rate. Although engineers estimate that more than 80% of mechanical parts are unique to Gen 3, the AI computer, cooling manifold, and 4680-based batteries are lifted directly from the Model Y bill of materials, preserving vendor continuity and existing PPAP approvals. The line's current takt, about 500 robots per month, roughly twice. Boston, Dynamics-IQ Industrier Kreisherr 2024 spot output offers Tesla ample capacity to validate tooling and processes before shifting high-volume production to Gigafactory Texas in late 2026. Capacity allocation disclosed during the May earnings call targets 300 bots in the third quarter across Tesla's Fremont, Austin, and Berlin for pick-and-place logistics, followed by 2,000 units in the fourth quarter dedicated to parts kitting. Internal time and motion studies show Gen 3 already hits 23 picks per minute on Model Y clip trays, within 18% of a trained human while logging wrist torque spectra for gearbox redesign. Deployment remains in-house until statistical MTBF tops 4,000 hours. Only then will Tesla lease X-Factory robots to Tier 1 suppliers that already reside on Gigafactory campuses, minimizing field service overhead. To avoid the kind of messy integration issues that slowed down earlier industrial robots, Tesla plans to release version 0.9 of the Optimus software development kit around the middle of the year 2026. This update will include a user interface that makes it easier to manage tasks, set up feedback systems, and create safety zones that users can define themselves. At first, the testing slots will go to companies that already run Tesla's energy storage systems, so that the same maintenance teams can look after both the energy packs and the robots. According to the early documentation, the robots' behavior updates are relatively small, less than 150 megabytes, and can be downloaded wirelessly and run on the same computer chip used in Tesla's self-driving cars. This helps make everything simple and smooth for business partners. Looking ahead, Elon Musk is aiming to eventually sell each robot for about $25,000. That would require Tesla to bring down the cost of making one to around $17,000, leaving room for about a 35% profit margin. Right now, though, building a single test unit still costs close to $118,000. Most of that cost comes from high-precision motor parts, advanced carbon fiber components, and complex wiring systems. Do you think having a robot that just knows what you want is exciting or a little bit scary? Would you feel comfortable having an Optimus bot in your home? Please share your opinion in the comments section below this video. Thanks for watching our video. If you want to explore more exciting information about Tesla EV or Tesla Bot, don't forget to hit the like button and share this video. Also, make sure to subscribe to Tesla Car World and turn on notifications so you never miss our latest videos.
Tesla, I'm calling it a very significant threshold would be the ability to learn from watching a video.
Elon Musk just pulled the curtain on Tesla Bot Gen 3, and the upgrade is nothing short of audacious. In the latest twin demo reels, Optimus doesn't just dance. It executes ballet pirouettes, shuffle steps, and a flawless trash pick and vacuum routine, all driven by a single neural network. Engineers say the bot now teaches itself over 100 new tasks a day by binge-watching YouTube, slashing a human's learning curve from weeks to minutes, while Tesla stock quietly popped 3% on release. From tearing paper towels to closing curtains, Gen 3 has graduated from party trick to full-time homemaker, and it's coming to market as late as this year. Ready or not, welcome to Tesla Car World. How can Tesla effectively safeguard Optimus against hacking and harmful learning?
Robot is safe. I think it's going to be very important to have a local means of turning it off.
Safety is going to be extremely important. I can't emphasize that enough.
As Tesla's Optimus robot advances, public curiosity and concern about its safety, security, and learning capabilities have surged. Could someone hack Optimus and turn him into destroying his surroundings? Others express fears about robots learning harmful behaviors, with comments like, "I hope they robots don't watch Hitman or some horror movie," and concerns about accidents will be intentional. Imagine this. There's a robot out there that can teach itself 100 new tasks a day just by watching YouTube videos. Sounds like something out of a sci-fi movie, right? Now picture that same robot accidentally learning how to fight, sabotage something, or even use a weapon. Yeah, now it sounds more like a sci-fi horror movie. But welcome to the age of real-world AI, where conversations like these aren't just bar talk anymore. They actually matter. So, what's Tesla doing with its robot Optimus? Before we jump to any doomsday conclusions, it's worth taking a closer look at how Optimus learns, and more importantly, how Tesla controls what it learns. Unlike some AI systems that wander around the internet unsupervised, Optimus isn't out there binge-watching random cat videos or rogue influencers teaching it how to pick locks. Tesla carefully handpicks the training data. We're talking educational material, approved instructional videos, and vetted user demonstrations. Think of it like AI with strict parental controls, only beefed up. If there's any content that includes violence, weapons, sabotage, or anything illegal, it gets flagged, filtered, and tossed out before Optimus even gets a glimpse. No sketchy content allowed. And no, Optimus doesn't just watch a video and then try it in your kitchen or on your factory floor. That's not how this works. Tesla uses simulated environments first, kind of like a digital playground where Optimus can try, fail, learn, and try again. So if it watches a chef cooking a steak, it won't grab your frying pan the next minute. It'll first practice moving billions of times in a virtual world until it gets it 99% right. Only then does it step into the real world. It's a safety-first approach that makes accidents very unlikely. Now let's talk about the big scary question: hackers. Yeah, nobody likes that word, especially when you're talking about something that moves, thinks, and can lift heavy stuff. Could Optimus be hacked? In theory, any connected system could be, but Tesla's no rookie here. Their entire ecosystem, from their cars to full self-driving, has been built with cybersecurity in mind. The same goes for Optimus. It'll have encrypted communications, digital ID checks, and limited local access. This isn't a robot you can just walk up to and reprogram like a toy. Think of it more like a Tesla car. It only takes orders from registered users, gets updates from Tesla's secure cloud, and if things ever go sideways, it can be shut down remotely.
You won't even need to. It'll figure out what you probably want and do what you probably want without you even having to ask.
Recently, Tesla released a series of demonstration videos showcasing what its Optimus robot can actually do. These clips gave the public a closer look at how the robot functions and, more importantly, how it's trained. In the videos, Optimus performs various household tasks: stirring food in a pot, vacuuming, sweeping the floor, taking out the trash, and wiping down surfaces. While these tasks may seem simple on the surface, they're actually the result of a highly advanced AI system trained through human motion capture data, not just from casually watching YouTube videos. Milan Kovac, head of the Optimus program, has mentioned that one of Tesla's goals is to enable Optimus to learn tasks like cooking and cleaning by observing third-person videos of humans doing them. Understandably, this raises concerns from the public. What if the robot accidentally watches something violent, like a scene from Hitman or a horror film? Could it learn something harmful? Tesla's engineers have clarified that this isn't how Optimus currently learns. It doesn't pull random videos off the internet. Instead, training is done using carefully controlled motion capture in supervised environments, similar to how Tesla curates data for its full self-driving systems. All video inputs go through rigorous filtering to block out any violent, illegal, or inappropriate content before it ever reaches the robot. So the chances of Optimus learning dangerous behaviors are incredibly low. Technically, Optimus is built on Tesla's existing autonomous driving tech, known for its strong cybersecurity foundations. Optimus is programmed to focus on safe, practical tasks, like sorting objects or navigating factory floors. It also uses input filtering, meaning that if you give it a vague or unsafe command like "cook me," it'll reject it as invalid. Plus, all of its actions are still under human supervision at this stage. While some critics on X have expressed concerns about unintended behavior due to training flaws, Tesla is actively addressing these issues using techniques like adversarial training and strict data integrity checks to prevent malicious data from slipping through. In short, what Optimus is doing today, whether it's mopping the floor or preparing food, is the result of a tightly controlled training process, not the result of random internet browsing. While long-term ethical questions about autonomous learning remain valid, Tesla is clearly prioritizing safety and control right now to make sure Optimus becomes a helpful assistant, not a potential threat. So are the demo videos of the Tesla Bot Optimus believable? Does it really do what it says, or is it just a show Tesla has put together? As impressive as Tesla's Optimus robot looks in recent videos, pouring drinks, folding laundry, vacuuming floors, many viewers are asking the same question. Is any of this actually real, or is it just clever editing? It's a fair question. Posts on X reflect growing public skepticism. Some users bluntly wrote, "Fake, video has been sped up." Another dismissed it as staged demos. And you're not alone. When a humanoid robot appears to flawlessly carry out complex tasks, it's natural to wonder if there's a little movie magic involved. At Tesla's We Robot event on October 2024, Optimus bots wowed attendees by walking around, playing games, and even serving drinks. But after the show, reports surfaced revealing that many of these interactions were assisted by human operators behind the scenes. The AI was only partially in control, mostly helping the robot walk and balance, while the real actions were directed via remote control. Think of it less like the Jetsons and more like Disney animatronics with Wi-Fi. This wasn't the only instance that raised eyebrows. In another widely shared video posted by Elon Musk on January 20th, 2024, Optimus is seen folding a t-shirt on a table, seemingly unassisted. But if you look closely, a human hand briefly enters the frame. That one small detail suggested the scene may have involved teleoperation, where a human remotely controls the robot to simulate autonomy. For many viewers, this immediately called to mind other infamous tech demos that were later revealed to be more show than substance. Remember Boston Dynamics robots doing backflips? Those were real, but required extensive programming and failed many times before getting a clean take. Or Google Duplex's eerily realistic AI phone calls? That blew people away, but later scrutiny revealed it worked well only in very specific, curated scenarios. So where does that leave Optimus? To be fair, Tesla isn't faking everything. The company has made genuine progress. Newer demos show Optimus learning from a unified neural network, meaning it doesn't rely on hard-coded instructions, but instead trains on videos of humans performing similar tasks. That's a huge leap in AI capability. But while this makes Optimus appear intelligent and capable, it doesn't mean it's fully autonomous or error-free. Just like a chess-playing AI might beat a grandmaster one day and fail the next due to an unexpected bug, robots, even the flashy ones, are still a work in progress. Tesla's approach is similar to how its full self-driving cars learn, through video data, trial and error in simulations, and tightly supervised real-world tests. It's not magic. It's millions of iterations and safety checks. Still, that doesn't stop people from asking if the videos they see are sped up, edited, or overly choreographed. And there's some truth to that concern. In many cases, Tesla has admitted to using sped-up footage. For example, in earlier demos, Optimus moved sluggishly in real time but appeared more fluid when the video was played at 1.5 times speed. This might make sense from a marketing perspective. It's more exciting, but it also blurs the line between genuine capability and promotional polish. Tesla's Optimus robot is real. Its capabilities are advancing rapidly, and it shows true promise in fields like manufacturing, logistics, and eventually home assistance. But not every video represents reality as it is today. Some clips may be enhanced, selectively edited, or partially staged. That doesn't mean the robot is a fraud, but it does mean viewers should watch these demos with a critical eye. What happens if a Tesla bot is knocked over in a crowded environment, like a restaurant? Or can the bot detect structural obstacles like wires, steps, or furniture legs while walking?
That Optimus is not a canned video. It's not walled off. The Optimus robots will walk among you.
Tesla's Optimus robot has demonstrated promising capabilities in controlled environments, showcasing tasks like walking, object manipulation, and basic navigation. However, its performance in dynamic real-world settings, such as crowded restaurants or homes with various obstacles, remains an area of active development and interest. Optimus is equipped with sensors and AI algorithms designed to help it navigate environments. In demonstrations, it has shown the ability to walk on uneven terrain and adjust its gait to maintain balance. For instance, a video released by Tesla depicted Optimus traversing rough ground, indicating progress in its mobility systems. When it comes to detecting obstacles like wires, stairs, or furniture legs, Optimus utilizes vision systems and machine learning models trained to recognize and respond to such challenges. This is akin to how autonomous vehicles detect and react to road conditions and obstacles. However, the effectiveness of these systems in highly dynamic or cluttered environments is still being tested and refined. One of the most pressing concerns about any humanoid robot operating in a real-world crowded environment, like a restaurant, shopping mall, or factory floor, is what happens if it falls? Can it get back up safely without damaging itself or others nearby? Tesla has begun to address this question through recent updates showing Optimus practicing basic recovery maneuvers. In one video, the robot is seen slowly lowering itself to a sitting position, then shifting its weight onto one arm and using the other arm and both legs to push itself back into a crouched posture. From there, it carefully extends its knees and recenters its balance before rising upright again. This motion is not unlike how a person with limited mobility might get off the floor, deliberate, slow, and calculated to avoid tipping over again. Optimus uses joint torque sensors and gyroscopic feedback to constantly monitor its body orientation. When it detects a deviation, such as a fall or wobble, it adjusts its limb positions in real time to compensate. During these tests, the robot moves cautiously, pausing at each key stage to stabilize itself before proceeding. So far, most of these recovery motions have been demonstrated in lab or test floor conditions, flat, obstacle-free surfaces with plenty of room to move. Tesla hasn't yet shown Optimus falling in a cluttered or public environment, like in between restaurant tables or next to sharp-edged furniture, but the foundational mechanics are clearly being developed. Tesla's engineers are also reportedly using simulation environments to train Optimus on thousands of fall scenarios, just as they do with autonomous driving. This allows the robot to learn how to recover from different angles, impact levels, and surface types, like carpet versus tile versus uneven ground, without having to physically fall each time. It's important to note that unlike Boston Dynamics' Atlas, which can recover from flips and aggressive pushes, Optimus's movements are still more reserved and utilitarian. It's not trying to perform acrobatics. It's designed for safe recovery that prioritizes control over speed or flair. How will the Tesla Bot Optimus work without internet connection? One common question that keeps popping up among folks following the rise of Tesla's Optimus robot is this: can it actually work without an internet connection? What happens if you're in a remote area or Wi-Fi cuts out? Will the robot just stand there like a statue, or can it still do its job? Yes, at least to a point. Tesla has designed Optimus to operate in both online and offline modes, much like its full self-driving system in Tesla vehicles. When a Tesla car loses connection, it doesn't stop driving. It relies on its onboard computer and preloaded data. Optimus works in a similar way. Under the hood, Optimus is powered by Tesla's in-house FSD Computer 2, which boasts 144 trillion operations per second of processing power. That's more than enough for real-time decision-making, object detection, path planning, and basic task execution, all without needing cloud access. So what can it actually do offline? Let's say Optimus has already been trained to perform a list of tasks: fold laundry, sweep the floor, or make a cup of coffee. These aren't tasks it figures out on the fly every time. Once a skill is learned, it's stored locally, kind of like how your smartphone keeps your favorite playlists downloaded for offline use. Based on industry estimates and onboard storage capacities similar to Tesla vehicles, which use 256 gigabytes to 1 terabyte of onboard SSD storage, Optimus could likely store hundreds to thousands of learned tasks, depending on complexity. For example, a simple task like sorting objects by color might use a few megabytes. How does that stack up against rival humanoids? Figure 01 grabbed headlines in early 2024 for making coffee after a 10-minute video lesson, but reviewers noted the clip gave no proof that the robot wasn't being chaperoned remotely. Even the company blog concedes viewers must assume the video is not faked. At Tesla's event later that year, critics discovered the Optimus units mingling with guests were also heavily teleoperated, voice replies and gestures piped in by hidden staff. The difference today is that Tesla has since shown the same household tasks performed in its lab with all radios switched off, something Figure has yet to demonstrate publicly. If you owned an Optimus that could store thousands of offline skills, which 3 everyday chores would you first trust it to handle, and why those over the rest? Please share your opinion in the comments section below this video. Thanks for watching our video. If you want to explore more exciting information about Tesla EV or Tesla Bot, don't forget to hit the like button and share this video. Also, make sure to subscribe to Tesla Car World and turn on notifications so you never miss our latest videos. We appreciate your support and look forward to seeing you in the next video.
One of our robots did the Trump dance, which I thought was pretty cool. So yeah, our robots can dance, they can walk around, they can interact. I think we're headed to a radically different world.
Oh my God. Instead of walking like Biden, Tesla Bot Optimus Gen 3 now has a full-on Trump-style dance. If you ever thought Optimus was just some gardening robot, a domestic helper, a cook, or a flashy tech toy, forget it. The latest video shared by Tesla and Elon Musk reveals a new leap in human advancement. Right here, Tesla Optimus isn't just walking, it's dancing, hip-swaying, and balancing on one foot completely independently, with zero external support or intervention. Even more surprising, Elon Musk himself and others have confirmed that what we're witnessing isn't some polished computer-generated imagery or AI trick. It's real-time dynamic balance and control. So what exactly has the Tesla Bot Optimus accomplished in the latest update video carefully released by Elon Musk? And what do these new updates mean for the potential sale of Tesla Optimus later this year? Welcome to Tesla Car World.
My prediction actually for humanoid robots is that ultimately there will be tens of billions. I think everyone will want to have their personal robot. You can think of it like as though you had your own personal C-3PO or R2-D2, but even better. Then who wouldn't want to have their own personal C-3PO or
What major upgrades has Tesla Bot Gen 3 achieved ahead of its official sale? Gone are the days when Optimus merely shuffled across a stage or performed a set of pre-programmed hand gestures. In the latest clip, the robot jumps, balances gracefully on one leg, and shifts its weight with fluid precision, all while its safety tether remains slack. For the first time, a mass-production prototype is demonstrating this level of composure, underscoring Tesla's aggressive push from research to full-scale production. Tesla Optimus showcases a striking display of coordinated movement, executing controlled jumps while shifting its weight seamlessly from one leg to the other. What stands out immediately is the unmistakable sense of rhythm, balance, and composure. The robot doesn't stumble, it doesn't falter. Then comes the defining moment. Optimus lifts one leg and holds the pose effortlessly. It's in that stillness that the truth becomes clear. This isn't a programmed routine or puppet-like automation. What we're witnessing is dynamic, real-time control. This level of precision isn't achieved with basic servos or mechanical repetition. It demands a highly advanced integration of inertial control and continual adjustment of the robot's center of gravity. Each joint responds through refined torque modulation, guided by ultra-high-frequency sensor feedback loops. Most remarkable of all is the robot's ability to maintain or regain balance even when encountering disturbances, something that remains an enormous challenge in humanoid robotics. In contrast, most humanoid robots today still rely heavily on safety harnesses just to stay upright. And even then, their movement often appears rigid, uncertain, or wobbly. Tesla Optimus, however, is beginning to move with the confidence and control that mark a genuine breakthrough. What Optimus demonstrates here isn't just mobility, it's performance. While many viewers have reacted with astonishment, others remain skeptical, asking, is this real or is it AI generated? But when we compare the footage to prior public demonstrations, such as the Wii Robot Showcase in October 2024, and Tesla's most recent internal update shared in April 2025, the clip aligns perfectly with Optimus's known capabilities. Now, Tesla Optimus isn't just walking, it's doing so with theatrical flair. This isn't a dance meant to flex muscles for show. It's a bold expression of how far dynamic control has come. What we're seeing is not just a display, it's a leap forward in robotic movement intelligence. To reinforce that observation, Milan Kovac, a Tesla engineer working on the Optimus project, reshared Musk's post and commented, "More coming shortly. The team has been working very hard in the background, entirely trained in simulation with RL. Many optimizations and fixes have been put in place in our sim-to-real training code and the tether on its back. It's likely there for safety, not for support. In industrial testing, robots are often secured in case they fall. But take a closer look. The line goes slack. That bot is standing and moving entirely under its own power." Kovac also addressed the visible cable attached to the robot, offering a direct response to the skepticism. The cable is there in case of a fall, not actually holding the bot, since this is an early result which will get more stable very quickly. He explained, effectively confirming that the tether is for safety, not support. To further validate its authenticity, Kovac shared some key details about Optimus's second demonstration that followed immediately afterward. According to Tesla's CEO, the humanoid robot's movements in the video are entirely in real time. The performance was fully learned in simulation and transferred zero-shot to reality without any additional training. Here's a little more, and no cables this time. It's all real-time speed, zero CGI, fully learned in simulation, and zero-shot transferred to real. Besides the fact that it's fun, we had to make significant improvements to our robot model in sim, domain randomization and other techniques which will directly transfer to more practical situations as well, robust walking, and agile full-body control in general. We also learned quite a few things on our hardware and tuned our power profile. I hope it is getting pretty clear that Tesla is much more than an amazing car company. It's the place to be for transformational real-world AI. This isn't the first time Elon Musk has used social media to reveal new capabilities of the Optimus line. Back in December 2024, he shared footage of the robot walking across uneven terrain in a garden. The video was captioned, "Optimus can now walk over highly variable ground, using a neural network to control its electric limbs." Musk ended that post with an open invitation for engineers to join Tesla's AI division, calling it an opportunity to work on exciting real-world AI systems. By 2022, the first functioning prototypes had emerged, demonstrating basic movements such as walking and lifting objects. In 2023, Tesla introduced Optimus Gen 2, which could perform yoga poses, sort objects by color, and execute more coordinated motions, including early attempts at dancing. The latest dancing video, however, marks a significant leap forward in real-time motion planning, showcasing just how far the robot's capabilities have advanced. At the heart of this breakthrough lies Tesla's simulation-first approach. According to Milan Kovac, every movement is refined within the Dojo supercomputing environment, where reinforcement learning teaches the robot how to shift its center of gravity and adjust joint torque using feedback loops accurate to the microsecond. Unlike traditional demos powered by basic servo motors, Optimus relies on 40 custom-designed electric actuators distributed across its limbs and torso to execute real-time inertial corrections while in motion. This sim-to-real pipeline, combined with high-frequency sensor fusion, enables the robot not only to recover from disturbances, but also to perform choreographed sequences with rhythm and grace. Equally compelling is Tesla's transition into limited-scale production. According to Tesla's first quarter 2025 shareholder letter, the Fremont factory has begun manufacturing units for internal use, with over 1,000 robots expected to be assembled this year. The company aims to begin external sales as early as the fourth quarter 2025 or early 2026. Elon Musk envisions a future where Optimus becomes as common as the Model 3, with a price point between $20,000 and $25,000, an affordable range for the mass market that no other humanoid robotics company has dared to promise. To achieve this goal, Tesla is developing assembly lines capable of producing 1,000 robots per month, with plans to scale up to 10,000 and ultimately 100,000 units per month at next-generation manufacturing facilities. This industrial muscle is what transforms Optimus from a research curiosity into a scalable labor platform with world-changing potential. So, how could a Tesla Bot Gen 3, you doubt, become your trusted companion?
Once you have humanoid robots, the actual economic output potential is tremendous. It's really unlimited. Potentially, we could have an economy 10 times the size of the current global economy, where no one wants for anything.
After all, until now, robots that help around the house have been prototypes, laboratory curiosities, or expensive novelty gadgets. But what if I told you that, as of mid-May 2025, Tesla's humanoid robot is poised to become the most reliable household companion you could ever ask for, at a price that won't force you to remortgage your home? First off, let's address the elephant in the room: trust. You're a practical man who remembers when hoverboards were supposed to change the world, only to leave a trail of recalls and burnt-up batteries. You've heard grand promises about mass-market robots before and seen nothing but vaporware. So why should you believe that Optimus will be any different? Tesla's approach is rooted in real hard numbers and a production pipeline already humming at the Fremont factory. In the first quarter of this year, the plant quietly assembled its first 1,000 units. No fanfare, no flashy PR, just straight-up manufacturing. These aren't one-off prototypes. They're the very same machines planned for sale in 2026, each one built using the same assembly line techniques that made the Model 3 a global bestseller. When we talk about price, the skeptics often point out that home care robots have traditionally been wildly expensive. Think six figures? Easy. By contrast, Tesla is aiming for a sticker price between $25,000 and $30,000. Break that down, and you'll see it matches roughly 5 to 6 years of in-home caregiver costs here in the US, which often hover around $50,000 per year. In other words, after you've paid off Optimus in about half a decade, you'll be enjoying round-the-clock assistance at essentially no extra cost. That's an idea that even the savviest retirees can appreciate. A one-time investment for decades of daily support versus an endless stream of monthly invoices. Of course, money matters little if the machine can't do the job. That's where the real magic happens. Each Optimus is equipped with 40 custom electric actuators, giving it the strength to lift 20 kilograms in each arm. Picture your laundry basket piled high with clothes. Optimus can scoop it up, carry it, and help you fold it without breaking a sweat. Climbing stairs can be nerve-wracking when you're alone, but with its advanced balance system, Optimus senses shifts in weight and adjusts its posture in real time, so it can brace you gently as you take each step. This isn't stiff, robotic stumbling. This is smooth, human-like movement that adapts to you, not the other way around. Medication management is another area where Optimus shines. Missing a pill can lead to serious health issues, and traditional reminders, sticky notes, alarm clocks, still leave plenty of room for error. Tesla's solution is a built-in scheduler trained on their Dojo supercomputer, which runs millions of simulations to learn the precise timing and context of your prescriptions. Field tests have shown a reduction in missed doses by up to 75% compared to old-school methods. Better yet, each reminder and confirmation is logged securely on the robot itself, so when you visit your doctor, you can simply hand over a digital record instead of fumbling through pill bottles or trying to remember if you took that morning dose. It isn't just big tasks that Optimus handles well. Even chores that seem small, like folding a shirt or carrying a carton of eggs, can become taxing when mobility is limited. In demos, Optimus folded an entire outfit in 30 seconds flat, or carried a fragile dozen eggs across a countertop with 0 breakages. Its high-frequency sensor feedback system constantly monitors pressure and position, adjusting grip strength on the fly. That means it can stack dishes, set the table, or even dust furniture without leaving a single fingerprint. All those little jobs that pile up and drain your energy? Optimus quietly takes care of them so you can spend your time reading a good book, catching up with an old friend, or simply enjoying a cup of coffee in peace. I know what you're thinking. What about safety? What if Optimus glitches, loses power halfway through a task, or, heaven forbid, falls on you? Tesla engineers have thought of that too. Optimus carries a dual battery system with 2 hours of backup power, and its motors and joints are outfitted with torque sensors that spot anomalies before they become serious problems. If the robot detects any imbalance or hardware fault, it enters a controlled shutdown, gently lowering whatever it's holding and assuming a support hold stance until a human helper arrives. In the unlikely event of a system crash, the machine is programmed to freeze in place rather than jerk or collapse, so you're never left in a dangerous situation. Let's talk about privacy, because inviting a robot into your home raises obvious questions about data security. Optimus processes 90% of its data on board, right there inside its own secure processors. Video and audio recordings never leave the device unless you explicitly choose to share them. All logs are encrypted with industry-leading 256-bit encryption, and health-critical records live in a separate digital vault that even a security breach elsewhere can't touch. Plus, Tesla plans to open their algorithms to independent audits by ethicists and cybersecurity experts, ensuring the robot's decision-making remains transparent, unbiased, and firmly in your control. Even with all these safeguards, it's natural to feel cautious. That's why Tesla is planning flexible purchase options tailored for folks like you. You'll have the choice of a $5,000 down payment, followed by $500 monthly installments, complete with comprehensive warranty and insurance coverage. For those who'd rather kick the tires before buying, there's a risk-free 30-day trial with 24/7 technical support and a full refund guarantee if Optimus doesn't meet your expectations. And for the most safety-focused users, there's a Medicare Safe mode that limits the robot's top speed and disables non-essential features unless you confirm them with a second command. All of this comes together to make Optimus a genuine partner, not just a gadget. Imagine the relief of knowing that when you need help, you won't have to wait hours for a caregiver to arrive. Picture yourself moving through your home with confidence, reassured by a gentle but capable helper at your side. Think about the peace of mind you'd gain from having your medication schedule managed flawlessly, and the delight of tackling those household chores without lifting a finger. Yes, Optimus still has to prove itself in real-world homes, and it may take a few more months before the first customer units roll out. But based on what Tesla has achieved so far, quietly building production-ready robots that combine strength, finesse, and intelligence at unprecedented scale, it's hard to dismiss this as vaporware. If you've ever dreamed of a personal assistant who's always there when you need it, and never asks for more than a little electricity and a software update, then Optimus might just be the friend you've been waiting for. And when those first machines start working in homes across the country, you could be among the first to welcome a new era of independence, safety, and peace of mind. So are you willing to hand over your most private moments to a machine that's only just learned to dance? And how comfortable would you feel relying on Gen 3's promise of safety when you've seen prototypes stumble and fall? Please share your opinion in the comments section below the video. Thanks for watching our video. If you want to explore more exciting information about Tesla EV or Tesla Bot, don't forget to hit the like button and share this video. Also, make sure to subscribe to Tesla Car World and turn on notifications so you never miss our latest videos. We appreciate your support and look forward to seeing you in the next video. Goodbye.